They are currently digging the world's most expensive hole. Not for oil. Not for gold. But for a futuristic mountain city at 8,500 feet above sea level. Inside that mountain, engineers are carving out the B3 tunnel, a high-speed rail and utility backbone that will power one of the most ambitious projects ever attempted, NEOM. This isn't concept art anymore. This is heavy machinery, controlled blasting, and thousands of workers turning solid rock into infrastructure. Here is the engineering behind the Trojena mountain tunnels. If you've seen the viral renders of the line or the alpine resort of Trojena, you've seen the marketing. But behind the glossy visuals is something far more important: logistics. Trojena sits roughly 2,600 meters, about 8,500 feet, above sea level in the Sarawak Mountains. That altitude means steep gradients, hard igneous rock formations, extreme temperature swings, limited road access. You don't build a mountain city without first solving access. That's where the B3 tunnel comes in. The B3 tunnel is not just a tunnel. It's an underground transport spine. It's designed to carry high-speed rail into the mountain, move construction materials efficiently, house utilities, power, water, fiber, cooling systems, reduce surface disruption in fragile terrain. Instead of carving endless switchback roads up a mountain, engineers are punching directly through it. This is mountain-scale civil engineering. Tunneling at 8,500 feet isn't just about drilling. It's about rock mechanics. The Sarawak Range is primarily volcanic and granitic rock, dense, abrasive, and unpredictable. That means tunnel boring machines wear down faster. Drill and blast methods must be precisely controlled. Ventilation becomes critical. Rock support systems must handle stress redistribution. When you remove rock, the mountain pushes back. Engineers combat this with rock bolts, shotcrete lining, steel ribs, continuous monitoring sensors. Every meter excavated changes the stress field inside the mountain. At this altitude, road logistics are expensive and slow. Heavy trucks climbing steep grades burn fuel, increase emissions, and strain supply chains. A rail-based tunnel system moves larger loads per trip, operates in extreme weather, reduces surface congestion, protects the natural landscape. This is long-term infrastructure thinking. If Trojena is meant to host global events and permanent residents, it needs reliable internal mobility from day one. Now here's the part that makes this project go viral. Inside Trojena, there's a concept called the vault. It's essentially a vertical mountain village carved into rock, stack architecture embedded into the cliffside. The tunnels are not separate from this vision. They are what make it possible. You cannot suspend glass facades off a mountain without anchoring structural loads deep into bedrock. You cannot run climate control at 8,500 feet without massive underground utility corridors. The tunnels are the skeleton. The architecture is the skin. NEOM is estimated at around $500 billion in projected investment. That makes it one of the largest construction programs on Earth. But scale creates complexity. Workforce coordination, material supply chains, concrete production at altitude, water sourcing in an arid region, energy integration. And every one of those systems connects back to underground infrastructure. Mega projects fail when logistics fail. NEOM is trying to solve logistics first. Ventilation at elevation. Oxygen levels are lower. Machinery efficiency changes. Workers require controlled airflow systems. Thermal stress. Desert heat outside. Cooler rock temperatures inside. Expansion and contraction cycles must be modeled. Water management. Unexpected groundwater can destabilize excavation. Drainage systems must be engineered before finishing works. Future-proofing. High-speed rail systems evolve. Utility loads increase. Tunnels must allow expansion decades from now. This isn't just about digging a hole. It's about designing a 100-year system inside a mountain. Mega infrastructure defines eras. The Channel Tunnel connected nations. Mountain rail systems redefine trade routes. Underground metros reshape cities. NEOM is attempting to redefine how cities are integrated with extreme landscapes. Whether it succeeds or struggles, the engineering lessons will ripple across the industry. Because building at this scale forces innovation. Right now, inside the mountains of Saudi Arabia, machines are grinding through rock. Not for oil. Not for minerals. But for a vision of a vertical alpine city powered by hidden infrastructure. They are digging the world's most expensive hole. And if it works, it may change how we build in the harshest environments on Earth. If you want more deep dives into mega engineering and future infrastructure, subscribe.